Hello students, today we are going to see about progressions. So progressions are nothing but, generally people think they are arithmetic progression, geometric progression, harmonic progression, and they confuse with sequence and series. So what is the difference between both? Sequence and series is nothing but when an arithmetic progression is given like this, for example 1, 2, 3, 4. What we can say about this one? We can say this one is an arithmetic series. That means they have a common difference. So this is in a series. But what about sequence then? Then when we add everything, it is about the summation. The summation arithmetic progression is in sequence. The numbers are in sequence and we are finding the sum, that will be series. So there are three types of progressions, which are arithmetic progression, geometric progression, harmonic progression, and I hope you find you know the difference about it, but I discuss the basics here. So the basic of arithmetic progression is they have a common difference, as we discussed previously. So they differ, every term, every consequent terms will differ with a common difference. For example, a plus d, a plus 2d, like that. So nth term in an arithmetic progression will be defined as a plus n minus 1 into d. And not only that, because by using this, there are many problems that were designed on this thing, like the summation of n terms in an arithmetic progression. So what is the formula for that? It's n by 2 of 2a plus n minus 1 into d will be summation of n terms in arithmetic progression. So the thing here is all about finding summation or finding a particular term. These are the general models that were asked in this progression type. And sometimes they will ask about the sequence or the summation of the sequence given in a different method, like recently it was asked in your indoor examination. What is that? They have asked that 1 plus 1 by 2 plus 1 by 4 and so on, like that. We have to find the summation of that series. Okay, like that the questions were designed on this. So what else? Geometric progression. In geometric progression, we already know that it's just like arithmetic progression. It do have a relation between consequent terms, but here it is it's not difference but a common ratio. That means it will be like ar square, like that, and so on. Now here the problem comes. Whenever you find the summation of this series, then we may have two things that are going on there. One is convergent and another is divergent. That means if I go on add like this, ar square, it can go more than infinity. I mean, it can go more than any numbers, like it can go to infinity. But convergent means it will go and stop at one point. How do we know that whether a point is going infinity or going less than infinity, or coming to one point, or is convergent? So we have to know that first before applying the summation of GP. So the formulas of summation of GP will go like this. It will be a by 1 minus r if r is less than 1 and this is infinite series. What if it is not infinite series? What if it is a finite series in geometric progression? Then we have to see it like this: 1 minus r power n by 1 minus r if r is less than 1, and it will be reverse if r is greater than 1. So here we have to check whether the series is a convergent and divergent before applying that. So in the following models, I am going to discuss about that. And coming to harmonic progression. Harmonic progression is nothing but reciprocal of arithmetic progression. So here the terms like let me rub this one. In harmonic progression, if I say A, B, C are in harmonic progression, obviously the reciprocals 1 by A, 1 by B and 1 by C will be in arithmetic progression. Here always remember, whenever I say 2 or 3 things are in arithmetic progression or harmonic progression, there will be always one thing that you can prove, and you have to prove that is the difference between two consecutive terms has to be equal to the difference between other two consecutive terms, because that is the definition of arithmetic progression, right? Because the common difference, every term will be differing with common difference only, just like in geometric progression, which they differ with common ratio. That means second term divided by first term should be equal to third term divided by second term. Okay, so this thing has to be followed every time. And moving on, we have to know about arithmetic mean, geometric mean, and harmonic mean. How they have to be derived. Arithmetic mean is nothing but it's the middle number or the median of the progression in arithmetic. For example, A, B, C are in arithmetic progression. Then B would become arithmetic mean of A and C, that is A plus C by 2. That means the median. In same way, geometric progression. If I say A, B, C are in geometric progression, B would become geometric mean, but here the calculation will differ. B is equal to root over AC. If there are 4 terms, it would become, if there are 3 terms, it will become cube, like that. Okay, so in this way, we will find harmonic progression also. Harmonic mean will come as the reciprocal of, it's nothing but arithmetic mean of these 2 terms. If A, B, C, if A, B are 2 terms in harmonic progression, 1 by A and 1 by B will become arithmetic progression. So arithmetic mean of these 2 things will be 1 by A plus 1 by B by 2, which is nothing but 2AB by A plus B is the harmonic mean. Here we get A plus B by 2AB as arithmetic mean. Reciprocal of that will become harmonic mean. So these things has to be remembered whenever we go into solving progressions. And another thing which we have to focus is arithmetic mean and geometric mean inequality. So whenever you take this AM, GM and HM, all will be in this relation. AM, GM is equal to HM. AM into GM is equal to HM square, like that. They will differ in that way. So this inequality has to be used whenever you want to find any maximum values and minimum values. Okay, so whenever I want to find any maximum minimum value of any equation, I can use this AM-GM inequality. So this is the application of progressions that we are going to see in the next models, in the following models. So let's go. So the first problem, I think this is asked in indoor examination once upon a time. Fruits were purchased for rupees 350. 9 boys are ate 3/5 of them in 2 hours. 6 boys feel their stomach as full, so do not eat further. In how many hours the remaining fruits will get finished by remaining boys? So whenever we first see this question, it can be seen as a time and work question, and sometimes people will call it as a ratio question, but here a progression is there. Okay, let us see. So 350. So let the amount of fruits or anything were in terms of 350 only. There are 350 units. Let us say just 350 units because fruits are purchased for rupees 350, but they never mention that there are 350 units. But we can say it as, when we take factors, 70 into 5 or 50 into 7, whatever. Okay, you can factorize them in any format. Okay, so 350 can be expressed in terms of this. So these many units are there. Whatever it may be. 9 boys ate 3/5 of them in 2 hours. That means 9 boys or 9 units or 9 persons has consumed 3/5. That means 1/5, 1/5 and 1/5. Why I have divided like this? Because here it is saying it as 3/5 of the total portion. That means they have consumed 3 units. That means I can say 3 boys ate 1/5 unit. Now each was done in 2 hours only, because everything is done in 2 hours means each 3 boys each consumed only 2 hours and 2 hours, right? In 2 hours 3 boys can eat 1/5 of the portion. That's given. 6 boys feel their stomach as full. Now 6 boys are done with their food. That means only 3 boys are left. So for those 3 boys, eating the remaining portion, that is 2/5, has to be done in how many hours? As it is already given, 3 boys eat 1/5 of the portion in 2 hours. So 2/5 of the portion will be done in 2 hours. Sorry, 2 into 2, that is 4 hours. Okay, so this thing is in geometric progression if you observe it carefully. Okay, 3 hours, whenever you double this one, whenever this thing is double, this portion has to be double. Obviously everything has to be double. Okay, so it is 4 hours. Okay, you can apply that in ratios as well. Okay, coming to the next question, next model. The sum of third and ninth term of an AP is 8. Find the sum of the first 11 terms of the progression. So these are the models that were covered in Indore or Rohtak examination, the other IPMAT examination. So the difficulty level is expected to be in this format only. So see here, the third term. How can I write any term in an arithmetic progression? It is as a plus n minus 1 into d. And nth term can be written in this form. So third term can be written as a plus 2d. And the ninth term of that AP will be a plus 8d. So their sum will be 2a plus 10d is equal to 8. Okay. With this, some people can say that a plus 5d, the sixth term, will become 4. But this is redundant because the sum, the question is asking, find the sum of the first 11 terms of the progression. But we already know what is the formula for sum of 11 terms or n terms of any arithmetic progression. It will be n by 2, 2a plus n minus 1 into d. Or you can write it as sum of first term and last term. But we don't know what is sum and first term and last term, so we are not going there. We have to restrict ourselves to here. So when I apply that to 11 terms, it will be 11 by 2, 2a plus 10d. We already got 2a plus 10d, which is 8 here. So 11 by 2 into 8, that is 44. Okay, so we are applying the formula directly here. The sum of arithmetic progression in terms of arithmetic progression. Okay, let's go to the next one. Number of terms common to both arithmetic progression is 2, 5, 8, 11 up till 179 and 3, 5, 7, 9 up till 101 is. So number of terms common to both the arithmetic progression are. So if you observe this carefully, what is the common difference between this first for this first progression? It will be plus 3 and plus 3 and plus 3. Okay. Next, coming to this, it will be plus 2 and plus 2 and plus 2. Okay. If you observe carefully, they are not starting at the same point. Okay. But they are having a common terms 5 and 5. Next common term would be, if you observe this carefully, it has 11 and here also it will be 11. 11 will come in this series. But how to find these common terms like this? Whenever you mix two arithmetic progressions, we have to mix their common difference also. But how to mix? Yes, LCM. So the LCM of 3 and 2 would be 6. That means after 5, for every addition of 6 or common difference of 6, we will get another common term. That means first one would be 5 plus 6, it will be 11, and next it would be 17 plus 6, it would be 23, and so on, up till where I can get common terms up till the least maximum, the least final number. Among 170 and 101, 101 will be the least one. So up till 101, I have to find the numbers. So here, if I go on like this, from 5 to plus 6, up till where I can go? 5 plus n minus 1 into d, n minus 1 into 6, that should be equal to 101 or less than 101. If I go like this, minus 5, it will be 96. 96 divided by 6, it would be 1 and 6. So less than or equal to 16. N minus 1 less than or equal to 16 means n would be less than or equal to 17. So 17 would be the maximum term. But let's check it again. So if n is 17, so what will be the 17th term in this series? If it is less than 101 or 101, it will be okay. So 5 plus 17 minus 1, 16 into 6. So it is 101. Okay, 16 plus 16 into 6 is 96. 96 plus 5 is 101. Yes, our last term is valid. So from up till 101, we will get a common terms, that will be 17. I hope you understood this one. So let's go to the next problem. In this problem, this is what I am discussing about in the starting of the class. So whenever you get any series like this, first of all, let's see which type of series it is. Okay, one Can I write this in any type of progression? Yes. When I see these numbers 1, 11, 121, 1331, it's like 11 cubes or 11 parts, 11 exponents. So what will be the common ratio? Obviously 11, but there is a decimal, so let us write it as 1 plus 11 by 10 plus 121 divided by 100 plus 1331 divided by 1000, like that. That means, yes, you got it right. The series is 11 by 10 whole power 0, 11 by 10 whole power 1, 11 by 10 whole power square, and so on. So if I consider this as the first term 1, the common ratio will be 11 by 10. Okay. So they didn't give any finite number of terms, so I'll take it as infinite number of terms. Now the infinite sum will be, as we have discussed, for a geometric progression, infinite number of terms, the sum of infinite terms will be a by 1 minus r for r less than r. But what is our r here? It is 11 by 10. That means 1.1. So that means a by r minus 1 will be the answer. But if I apply that, a will be 1, r minus 1 would be 1.1 minus 1, that is 1 by 1 by 10. And if I get 1.1 by 1 by 10, the answer would be 10. But the answer is wrong. Do you know why? Yes, whenever I increase the numbers like this, if I go infinite, yes, the next term would be again 1 point something something else and something something else. But if I continue like this for infinity, the answer would be infinity. That means here the question is, the answer will be, the question is divergent. Okay, so whenever r is greater than 1 and the thing is not finite, the series is not finite, it will go divergent. Okay, if you understood this thing, this is an infinite series and r is greater than 1, so we cannot get a finite answer. So 10 here cannot be, even if you get a finite answer, that cannot be applicable here. Just observe this one, 1.1, if you add more than 10 terms, you'll cross 10 exactly, right? So like that we cannot get this thing. So you have to observe common ratio and the type of series it is and how many terms are there in that, whether it is infinite or finite. If it is finite, we can get easily a of r power n minus 1 by r minus 1. Okay, like this we can do it. So I hope you got the gist of this progressions. I'm not saying that every video I'm repeating this. These are not the only models that we have to concentrate, but these are the type of models that every IPMAT exam is touching you. Even in Indore, recently Indore, they have touched this type of question in recent MCQs. So I hope these things will help you in your IIM Kozhikode preparation as well. Thank you guys.